I remember the graphs of trigonometric functions are extra credit on your test, so I'm going to go over these pretty quickly. You'll notice that they're pretty small. You're not going to have all four different translations happening to all four of them at the same time, so they shouldn't take you too long if you attempt them. All right, so we've got two parameters here. You've got the 1/2, which is going to make this pretty small. That's its amplitude. All right, and then we've got the 3 in front of theta, and the 3 is like tucked inside the cosine value. So what we've got to do is say that the period is 2 pi over b, and we're going to use that b to get the period. So that formula will always be present, and it looks like we just throw in the 3, and that's the guy. Now, unfortunately, these are all pi over 4s. You will not have to worry about that on the exam. I will absolutely make sure that these guys are like fit the actual period. 2 pi over 3 is like, let's see, it's smaller than 3 pi over 4, but it's bigger. So it's like right around here, right around there. So that means that cosine is going to complete a full cycle from there to there. So we're looking at every 2.5 units here, he's going to complete a cycle. And I went half up, and then in between those, I go half down, and it's not pretty. Okay, but cosine starts at 1, and then from there, it keeps going. All right, so that's your guy there. All right, sine. Looks like we have 3 sine, and this is 1/4 theta. So 3 amplitude is not that big of a deal. Amplitude is the easiest piece, but period is 2 pi over b, and b is 1/4. So 2 pi divided by 1/4, that 4 is going to reciprocate twice, so we end up with 8 pi, which means that sine is going to complete his full cycle from 0 to 8 pi. So this is nice. We've got these clearly labeled, and we're going to start at 0 because that's what sine does. And then at 8 pi, he will return back to his original cycle. And every 4 pi's, he returns to the neutrals. I guess the neutral zone is what we can call it. So halfway between here, we have his amplitude go up to 4. Halfway in between these guys, we're going to have his amplitude go down to -4. And then it will repeat. Remember, if it doesn't look symmetrical, then something's wrong. Okay, that's the beauty of these trig functions. The waves require them to have symmetry constantly. All right, now we've got secant, which is a reciprocal function. He is related to cosine, and we know cosine does that. So if we go up to 2 here, I'm going to draw my midline, and I'm looking at this 2, not that 2. That 2 is going to give me a new amplitude, but this 2 means I'm lifting the whole thing. That's a vertical shift. And secant is related to cosine. So cosine starts at the very top, and we're going to go 2 units from the midline. He starts at the top. Then he's going to go a full 2 pi cycle here. And he's going to go here, so the symmetry here. Every 4 units then he'll return. Okay, looks symmetrical. Now, wherever he hits 0, we're actually going to have an asymptote. Okay, and this guy, oh, he doesn't hit 0 there. Oh, shoot. Darn it, he hit 0 here. Here and here and here. Okay, so I'm going to draw cosine in. Okay, so now this guy, let me use a different color. I really kind of messed that up. All right, so this means that at the very top of cosine, that is where we're going to squeeze in the little quadratics, or they might actually technically be hyperbolic curves, but that doesn't matter. Then this guy going down, he's the minimum. He'll have his going down. This guy will go up. And then this guy will go down. Okay? All right, remember, so secant is related to cosine. Here, cotangent is related to tangent, but you don't really need to know that. You need to know that cotangent goes from 0 to pi, where tangent actually goes from negative pi over 2 to positive pi over 2. Cotangent does this, okay? So every period of pi, cotangent completes a cycle. But if you remember, he also goes this way. All right, so there are no other things other than a vertical shift down to 2. So we can go here at negative 2. So he goes down 2. Then he's going to go over here 1, and he'll go over here 1. Okay, we've got an asymptote here as well. So this guy is basically just kind of looks like a cubic, and he'll just repeat that on both sides. Okay, so the graphs of these guys will be simple. You're not going to have a lot going on, but you will. This guy technically should go like that, and then this guy should come like that, and then that kind of completes the picture there. But you're only going to have a couple things going on, and remember, these are extra credit as well. Okay. All right, that's the study guide.